Alright, so we're looking at the inverse function. So we're verifying whether the inverse function of the function equals x and whether the function of the inverse function equals x. Alright, that's fun to say. Alright, so let's look at the function f of x equals x cubed plus 2. So the inverse function would be, if we just change our x's and y's, actually I'm just working this out. So y equals x cubed plus 2, I'm going to make x equal y cubed plus 2 for my working out. And I'm going to make y cubed the subject. So y cubed is x minus 2. I'm going to cube root both sides. So I've got the cube root of x minus 2. So therefore, my inverse function is the cube root of x minus 2. So now if I find the inverse of the f of x function first, alright, so I want to find the inverse of the f of x, where f of x, remember, is x cubed plus 2, right? That's my f of x function, or my y equals function. All right, and remember, here's my inverse function down here. So wherever I see an x now, I'm putting in x cubed plus 2. So I've got the cube root of x cubed plus 2 minus 2. All right, so wherever I saw x, that's where I wrote x cubed plus 2. Now if you think of that, we've now got the cube root of x cubed plus 2 minus 2, so it's just x cubed, which does indeed become, so if I cube a cube root or cube root a cube, I get back to x. All right, so that works. All right, so let's verify whether f of the inverse function of x works. So this time in the function, I want to put inside the function the inverse function. So I want to put inside the cube root this inverse function, cube root of x minus 2. So back in the function being x cubed plus 2. So wherever I see an x, I'm now going to do the cube root of x minus 2. So I'm going to have cube root of x minus 2, or cubed, plus 2. All right, so again, cubing a cube root, I just get x minus 2 plus 2. Again, I'm going to get x. So we verified that works for that first function. So let's look at the second function. All right, remember you can stop, pause, or try it before you go on. All right, looking at the second function, we've got f of x equals 6 minus 2x. So if I first have a look at just swapping the x and the y's, remembering that f of x is the same as y, and remember in this case it says x is greater than 0, so I know y is greater than 0. Again, if I put my y as my subject, so divided by 2, all right, remembering this is where y equals 0, so my inverse function here is 3 minus x on 2, where y is greater than 0. So let's have, this is y, so y is 3 minus x on 2. Where is that greater than 0? Well, minus x on 2 is greater than minus 3. If I times by a negative 2, times both sides by negative 2, I'm times it by negative, times it by negative 2. So I flip sign, that becomes x is less than 6. So this is correct for where x is less than 6. All right, so there's my inverse function. All right, so let's now verify, let's do f of, okay, so the inverse of f of x. Let's have a look at what that looks like. So I'm going to put in the inverse function the value of f of x, which is 6 minus 2x. So let's put that in. So wherever I see an x, I'm now going to put in 6 minus 2x. So 3 minus 6 minus 2x on 2, which is 3 minus, if you think about it different ways, but say I factorize that top by 2 so you can see it clearly. We have 3 minus 3 plus x, because minus times a minus is a positive. So we get back to x, so that works nicely. What about f of inverse f? There we go, f of x. All right, I'll just do it down here. So I'm going to put the inverse function in here, which is 3 minus x on 2, into the original function. So wherever I see an x, here we go, 2, then I see an x, I'm going to put in 3 minus x on 2. So what do I get? 6 minus 6 plus x on 2 times 2 is just x. So again, that equals x. Oh, good.